Welcome back. Here is chemistry course. This is lesson 3 now. I'm your tutor Klaus Ho. Let us get started. The scientific method follows a process similar to the one shown in this diagram. All the key components are shown in roughly the right order. Scientific progress is seldom neat and clean. It requires open inquiry and the reworking of questions and ideas in response to findings. The domain of chemistry. Chemists study and describe the behavior of matter and energy in 3 different domains: microscopic, macroscopic, and symbolic. This domain provides different ways of considering and describing chemical behavior. Macro is a Greek word that means large. The macroscopic domain is familiar to us. It is a realm of everyday things that are large enough to be sensed directly by the human sight or touch. In daily life, this includes the food you eat and the breeze you feel on your face. The macroscopic domain includes everyday and laboratory chemistry, where we observe and measure physical and chemical properties or changes such as density, solubility, and flammability. The microscopic domain of chemistry is almost always visited in the imagination. Micro as comes from Greek and means small. Some aspects of the microscopic domains are visible through a microscope, such as a magnified image of graphite or bacteria. Virus, for instance, are too small to be seen with the naked eye. But when we are suffering from a cold, we are reminded of how real they are. However, most of the subjects in the microscopic domain of chemistry, such as atoms and molecules, are too small to be seen even within the microscopes, and often must be pictured in the mind. Other components of the microscopic domain include ions and electrons, protons and neutrons, and chemical bonds, each of which is far too small to see. This domain includes the individual metal atoms in around the ions that compose a salt crystals, the change in individual molecules that result in a color change, the conversion of nutrient molecules into tissue and energy, and the evolution of heat as bonds that hold atoms together are created. The symbolic domain contains the specialized language used to represent components of the macroscopic and microscopic domains. Chemical symbols, chemical formulas, and chemical equations are part of the symbolic domain. As a graph and drawing, we can also consider calculation as part of the symbolic domain. These symbols play an important role in chemistry because they help interpret the behavior of microscopic domain in terms of the component of microscopic domain. One of the challenges for students learning chemistry is recognizing that the same symbol can represent different things in the macroscopic and microscopic domains. And one of the features that makes chemistry fascinating is the use of domain that must be imagined to explain behavior in a domain that can be observed. A helpful way to understand the 3 domains is via the essential and ubiquitous substance of water. The water is a liquid at moderate temperature, will freeze to form a solid at lower temperature, and boil to form a gas at a higher temperature. A microscopic observation. But but some property of water fall into the microscopic domain. What we cannot observe with the naked eye, the description of water as comprised of two hydrogen atoms and one oxygen atom, and the explanation of freezing and boiling in terms of attraction between these molecules is within microscopic arena. The formula H2O, which can describe water at either the microscopic or macroscopic levels, is an example of symbolic domain. The abbreviations for gases, S for solid and L for liquid, are also symbolic. Features 1.5. Moisture in the air, icebergs, and the ocean represent water in the microscopic domain. But at the molecular level, gas molecules are far apart and disorganized. Solid water molecules are close together and organized, and liquid molecules are close together and disorganized. The formula H2O symbolizes water and gases, and solid and liquid symbolizes phrases. Thick clouds are actually comprised of either very small liquid water droplets or solid water crystals. Gaseous water in our atmosphere is not visible to the naked eye, for it may be sensed as humanity. So this is the end of this lesson 3. I will see you next lesson. Thank you. I'm Carl.